In this crisp video, I am going to explain you all the components of working with outliers in machine learning. Let's see that. Here are the things we are going to cover as part of this video. So we are going to understand definition of outlier. Then we are going to see types of outliers. This may be asked to you in the interview. And then we are going to discuss what is the impact of outlier in your analysis. Okay. And we are going to see how to find outliers different ways in Python, how to work with outliers in Python, which means once we find outlier, then how to work with that. And then what are the other options if you have outlier in your data. Okay. All these things related to outlier will answer a lot of interview questions for you. And it's good to have all this information in one place. Hence, I'm creating this video. Okay. So let's go ahead and try to understand what is the meaning of outlier. Okay. So suppose I put here salary of all the employees of an organization, right? So maybe somebody is making 1,000, somebody is making 1,100, somebody is making 1,200, somebody is making, let's say, 800. And suddenly I put the salary of the CEO here. Okay. So CEO salary may be 1 crore. Okay. So this 1 crore number is an outlier for this observation. Why? Because this number is very far from rest of the numbers. Outliers can be on both the sides. So outlier can be on higher side. For example, this is an upper end outlier, and outlier can be on lower side as well. For example, rest of the numbers are in the range of this. There can be a number, if we can take hypothetically 10, right? So this is a very, very low number. This will be called as a lower end outlier. Okay, so conceptually this is outlier, but there are some definitions, mathematical definitions, which numbers will be called as an outlier. We will see that. Okay. Second thing is, people may ask you what are the different types of outliers. So there are three types you should remember. First is called as a global outlier. Okay, I will tell you in a moment what is this. Second is called as a collective outlier. Okay, collective outlier. And third is called as a contextual outlier. Okay, contextual. What is the meaning of a global outlier? One simple example will be any one data point which is far from the rest of the data point and has no proper kind of justification, you can say, or we are not able to find out why that is an outlier. So a global outlier is something which is very, very far one data point from rest of the observation. For example, if I draw my observations like this, okay, if I draw my observations like this, and then suddenly I find a point somewhere here, then this point is far from rest of the points. So this will be called as a global outlier. Okay. So what is collective outlier? Collective outlier is most of your samples are lying here, but suppose a group lies somewhere here. Suppose a group lies somewhere here. So 2 or 3 group lies somewhere here. So this is an outlier if you compare from rest of the observation, but this is a group. So this is a kind of collective outlier. Okay. And this you can also think in terms of multiple columns also, it can be there. So not only one column, multiple columns also. And what is a contextual outlier? A contextual outlier is an outlier where you will have some context of that. For example, suppose IPL is happening in India. Okay, IPL is happening in India, and then you plot how many hours of TV average Indian watch, right? So your chart may look something like this, and in the IPL season maybe it will look like this. Okay, so maybe here, from here to here, it's an IPL season. So though this data point is an outlier, but there is a context to it. Okay, so this type of outlier is called contextual outlier. It needs a altogether different treatment strategy or different approach. Remember, in terms of outliers, don't jump into the conclusions from whatever you have learned in your training institutes or whatever you have learned in your classes, theoretical classes. Outliers can be in one of these categories or can be something which may not fall in one of these categories. Okay. So always you should try to take business input on how to work with the given outlier and what is the context, is there any capturing error. So talking of capturing error, right? There can be different ways in which outlier in your data can be present. Okay, so one way in which outlier in your data can be present is human error. Suppose somebody is capturing the data and they capture it wrongly, that will be human error. Another kind of outlier in your data can be intentional. Okay, intentional means somebody is knowingly putting it just to check your model performance or just to check how the system behaves in terms of extreme inputs. Okay, so intentional output can also be their outlier. Always, that's the reason I'm saying, always ask your business why this data point is there and then take your call. Okay, then your outliers in the data can be due to data processing error, suppose, or data capturing error also. I will give you one example of what is this. Suppose there is a sensor which is capturing temperature of a room and sensor is not working properly, so temperature of the room will not get captured properly, and in this capturing you may see some outliers. Okay, suppose there is a Python script which is working to pre-process some data and something goes wrong with the script, then you might see some outliers which is coming out from the data pre-processing. I am telling you all this so that you have a broader understanding of what kind of outliers you can see and what kind of uh, behavior it can show. Okay, and then it can be experimentation error. Okay, experimentation error. Don't worry, it's not too much of theory. I will go into Python now, but try to understand when some statistical experiments are, or some some simulations are going on, there can be some kind of experimentation error which can introduce outlier in your data. Okay, there can be more to it, but just remember there can be these kind of reasons for your outlier, and what are the different types of outlier I already told you. Now let's go to Python and try to understand how outlier will impact your model or behavior of your model. So let me go to my Python. Before that, guys, the reason I'm creating this video is, as you can see, I had created one video on missing value imputation. Okay, and in this 18 minutes video you will find all the information about missing value. So if many information about one topic is at one place, right, it's always good to revise. So if you want to revise everything about missing value imputation, you can go here and revise. Okay, and today we are covering outliers, so let's go here, and this is the part 1 where I'm going to show you how outliers will impact your model or screw up your model. Okay, so here I have imported NumPy. I have age column and salary column. In both these, I have some data. Okay. And I am fitting a linear regression model on this. So as you can see here, the accuracy of your linear regression model is 0.75. That means 75%. Okay. And just to revise some basics here for the newcomers in data science, this is how you find out the coefficient and this is how you find out the intercept. Okay. And this is how, without using the predict function, you predict the salary. Don't worry, I will give you this notebook. You can take it from my GitHub and you can use it. Okay, Unfold Data Science GitHub, you can take it and use it. So what I'm showing you here is, once you have the coefficient and intercept, you can create your own formula like this, and without using the pred function you can get the salary. And here I'm using the pred function. Okay, so both the cases I have some numbers and I have my accuracy matrix here. Don't worry about trend, test, split and all those things. That's not the idea here. I don't want to show you those details. I just want to show you how output will impact your model. Now what we are doing here, we are predicting one column with the help of other. Let's go ahead and add two more zeros here. By adding two more zeros, what I am doing, I am introducing an outlier in my data. Okay, now let's run the same model again. So see here, from 75% my accuracy has dropped to 39%. Why? Because I have just introduced a outlier here. Okay, so this is how your outlier will screw up your model, and it's very easy to understand how it will impact your model. So I'm fitting a linear regression there, as you saw. So on one column I have age, on other column I have salary. So I have age here and I have salary here, right? So these are my data points, for example, you can think of. So if my data points are like this, it's very easy for linear regression to fit a line to this. Okay, now suppose my one of my data point which is an outlier is somewhere here. Okay, now it becomes difficult for linear regression to fit a model, and linear regression will try to fit a model. In trying to fit a model, what it will do is it will try to do something like this or something like this. Okay, So all this is nothing but a bad model. And that is where your accuracy is dropping from 75 to 39%. Okay. Now let's move ahead and try to see how to find out the outlier. That is part 2, detecting outliers. Okay. So for this, I have taken a famous data set known as tips data, TIPS tips data. Okay. Which is there in the SNS C1 library. And what I'm going to do is, as you can see, it has total bill, tip, sex, smoker, date, time, size. So this is basically a restaurant data where you have total bill, tip, and etc. And this is how your DF looks like. Now, out of all these, I'm just going to use the numerical features here. Okay. So as you can see here, I'm separating my numerical features, which is total bill and size. And I'm separating my target feature, which is tip. And I'm going to fit the same linear regression model. So run this, and run this. I'm getting accuracy of 46% because I have some outliers in my model. Okay. I mean, I have some outliers in my features. So I will go here and I will see if my total bill column has outliers. So this is one way of looking if your data has outliers, that is known as box plot. So if I plot the box plot, I can clearly see some outliers are here. Okay, so this is one way of detecting outlier. Now, in the interview, I have seen people doing mistake where people interviewer will ask, how do you find out which points are outlier? And they will say by looking at the box plot. Now, by looking at the box plot, how do you know which points are outlier, right? So for example, if there are 100 rows in your data, how do you say that my row number 40 has an outlier, right? That information you don't get from here. So box plot gives you a glimpse of, yes, there are outliers in your data, but you need further code to find out where are those outliers. Okay. So this is about box plot. You can see the outlier. Now another method through which you can see the outlier is histogram. So in histogram, as you can see, it is somewhere this side, and towards 50 we can see some numbers. So this looks like an outlier. Okay, but we have still not seen the proper way of finding an outlier data point. Let's see that. So method one is called mean and standard deviation method. What you do is you find mean of the data and you find standard deviation of the data. Okay, and then you say anything which is above mean plus 3 standard deviation. Now remember guys, I have taken 3 standard deviation. You can take 2 standard deviation, 4 standard deviation, depends on you. Okay. So what I'm saying, anywhere my data point is greater than mean plus 3 standard deviation, I call that as an outlier. Okay. And this becomes my upper outlier. As I told you in theory, outlier can be upper and lower end both. Okay. So here this is your outlier upper. Similarly, if you say my number mean minus 3 standard deviation, this becomes your lower end outlier. So in our data from this definition, now pay attention here, definition of outlier is changing. Here I am saying mean plus 3 standard deviation. Here I am saying I can say 2 or I can say 4 as I told you. And here also. So in this method, I am getting these 4 upper outliers and no lower outliers. Okay. Let's see the other method that is known as AQR method. In AQR method, you compute your 25th percentile, 75th percentile, that is nothing but Q1, Q3. Then you compute your AQR, you compute your lower boundary, upper boundary, and if anything is below lower boundary or above upper boundary, you call that as an outlier. Okay. So this is your second method for finding outlier. What is the third method for finding outlier? Here you give a threshold like how many standard deviations or you want to go away and call that as an outlier. Okay, in both the directions. So here more or less I think mean and standard deviation method and this method is kind of resembling. Okay, but still you can set your threshold and you can find out the outlier like this. What is method 4? Method 4 is you are saying anything below 5th percentile or anything above 90th percentile, I will call that as an outlier. Now remember, there is no one size fits all. For example, if somebody tells you that this is the one and only one definition of outlier, you should not agree with that. Okay, because you define what is outlier for you. So I'm showing 4 5 ways of finding outlier. Any of the way can be suitable for your data. So good to know all these ways. Okay, so in this way you say that anything which is below 5th percentile is an outlier, anything which is above 95th percentile is an outlier. Okay, so these numbers are outlier in my total bill column. Fine. So data is my total bill column. If you can see here, where I have defined data. Yeah, here I have defined data. Data is my total bill column. So from here I am taking data 5th percentile, 95th percentile. Okay. Now let's come to part 3 where I'm saying how to remove outliers. So very first method that I want you to be aware of is log method, where whatever outlier you have, if you make it np.log base 10 or natural logarithm also, then your data will start coming into the shape if it is a right skewed data. Okay. Like in this case histogram you saw, right? So for this kind of data, if you do a log transformation, that helps. Okay. So remember, what is my model's accuracy? We are starting from 46%. Okay, this is my baseline model without any transformation. Now I will go and do log transformation and see what happens. Okay, so here I'm doing log transformation and here I'm plotting log transformation. So it looks little bit in shape now as compared to the previous one. So let's go ahead and fit the model. As you can see, model is not improving from 46, it is coming to 44%. So which means that one of the method, that is log transformation, is not helping in this case. So this is a very common scenario for machine learning. You do something that doesn't help you. It is perfectly acceptable, no problem here. But you should know that log is one method that we can use. Okay, let's move forward. Other method of working with outlier is called a binning method, where I say that anything in, I divide 5 categories: 0, 10, 20, 30, 40, 55, and I say that in this range call very low, low, average, high, and very high. So basically I'm creating 5 buckets in my total bill column so that my higher outliers, right, should come in very high category and my model performance should improve. Okay, so in binning method if I go, then my total bill binned will look like this. So first number will get converted to low, second will converted to low, and whatever is the value based on that, it will get converted to these 5 labels. Okay, now what I'm going to do is my df looks like this. So I'm going to remove the original bill and I'm going to use this column in my analysis now. Okay, the new binned column. So if you see here, I have just created one hot encoding of my new total binned column. Okay, so these new columns that you see is one hot encoded vector of the binned column. Okay, and now what I'm going to do is I'm going to take this and I'm going to run my model, removing the original bill column. What happened to the model? The model is not listening. The model is not improving. As you can see, model is not improving. Let's move forward to the third method. Third method is known as clipping method. Clipping method means I clip my lower end outlier at 5th percentile, upper end outlier at 95th percentile. Okay. So that is what I'm doing. In this case, I'm doing 1st percentile and 90th percentile. You can try with 5th and 95th as well, or 2nd and 98th as well. Okay. All those are different choices that we can make. What I'm saying is this np.clip is a numpy function. So if you Google this function, you will know that whatever range you give, right, it brings your data in that range. Okay, anything below that, it will bring it to lower. Anything above that, it will bring that to upper. Fine. So if you clip this, this is another outlier treatment method. And let me see if this is helping. Okay, so it is not helping. 36% again, not helping, but good to know. This is another method that is good to know. Okay, so this is how life of data scientist is, guys. You know many things, you try to use things, some of these will help you, some of these will not help you, and then you think what to do next. Okay, so now what I thought is, let me go ahead and see the distribution of total bill. So distribution of total bill is this. This is not the distribution of total bill, actually this is the size distribution, size. Okay, so my chart heading is wrong. Distribution of size. Size means how many people came to eat in the tips data set. Okay, so if you see the tips data set, right, how many people came to eat is one column I'm using, total bill is another column I'm using, and I'm trying to predict this. Okay, so let's come to total bill column, and here if you see clipping method I was talking, right? So this is the distribution of size column. So in size, what I saw is 2 is maximum. So I saw, let me create binning on size also. So I did that, size low and size high. Okay, and then I created a one hot of this like before. I'm doing feature engineering. Okay, I created one hot encoding of this like before, and I'm running my model now on total bill. Okay, that is the original column, then size low and size high. I just want to see what is the performance of my model on this. Okay, so my model is not performing great on this as well. Okay, not performing great on this as well. Then what I did is I'm just trying to show you how the flow of working with a model should be, right? Then I went ahead and I I thought, since I'm fitting a linear regression model, so why not I should see the relation between all the columns in the data. Okay, so as you can see here, this is a pair plot of the data, right? So for my linear regression to perform good, right? For my linear regression to, let me zoom it a little bit if I can. For my linear regression to perform good, right? At least I should see some relation in the scatter plot, which means at least some of the charts should show me a pattern. Then only my linear regression will work good. So as you can see, I can see just one relation, that is this relation here. Okay, that is little bit of relation. Apart from this, there is no relation at all. In this type of data, if you try to fit a linear regression model, you are not going to get a good result with basic feature engineering. You have to do some advanced feature engineering, or you have to see how you can tweak the data or bring in more data. Okay, so here what I did is I thought let's move far from regression model. Okay, and let's try to run a random forest. And as you can see, at the moment I ran a random forest, my accuracy jumps to 86% suddenly. Okay, why? Because this model is not suitable for a regression use case. Okay, the idea of this video is to show you two three things. One is how you go step by step in the analysis and how you implement things and see if it is not working, how do you go to the next thing. Then how do you see why it is not working? So I showed you charts, right? Why it is not working was very clear, because there is no clear pattern. Okay, and then can I go for an ensemble learning? Can I go for a different technique? Yes, I can go for a different technique. But in this journey, I wanted to show you different ways to find outlier, different ways to work with outlier. Okay, I want you to do little research on something known as isolation forest. Okay, do little research on isolation forest. That is another method to which will help you in outlier strategy. Now, having seen all these things, why do you think random forest perform good on this data in spite of this data having outliers, in spite of this data not having proper patterns? So remember, this is another interview question. Whenever somebody will ask you, I have a model and I have outliers, will my model get impacted by outlier? Remember, any model that uses distance based mechanism, okay, distance based method or mechanism, any model that uses distance based method will be impacted by the outlier, and you should not have outliers in your data if you are using one of these models. For example, linear regression, for example, logistic regression, both became LR, but you understand, right? And for example, KNN. Okay, and there are some more models, but I will not write because I want you to comment which are the distance based method that will get impacted by the outliers. Please comment down. Okay, and please do little research on something known as isolation forest that helps you to deal with the outliers. Okay, so I hope you like the idea of going step by step for doing various feature engineering and then seeing what is working, what is not working, and understanding the next step. Please give a thumbs up if you like this video. See you all in the next video. Wherever you are, stay safe and take care.